Hello all, welcome to VJD Academy. This is Anil Kumar, Faculty of Digital Electronics. Today, I would like to teach a small concept called comparator. Sir, to understand it is a small and to learn small, but it's a big weightage in competitive exam point of view. Let's learn it, and we have a 3 equations at the end I am going to teach. If you can able to understand those 3 equations, there is a mark which is in your pocket already. Sir, let's try to understand comparator. Sir, comparator, it is a, we can say that the first point of comparator, it is a combinational circuit. And the second point we would think about, there are 1 bit to 2 bit to 3 bit, 4 bit, 5 bit up to n bit comparator circuits we can draw. Comparators are many a types. 1 bit to 1 bit and 2 bit and up to n bit comparators are there. Sir, the third point, the number of inputs and number of outputs depends on the bit comparator. Number of inputs and outputs depends on what kind of 1 bit comparator or 2 bit comparator, n bit comparator, depends on its bit comparator. You will understand the meaning of this statement. Sir, here let me try to draw a circuit of comparator. Let me take 1 bit comparator, 2 bit comparator and n bit comparator also, and let us try to understand. Sir, here this particular comparator circuit is always its inputs may be varied, but outputs are fixed. Number of inputs and outputs depends on bit comparator. Please note down the number of inputs only, not outputs. The number of inputs depends on its bit comparator. That 1 bit comparator are we using, a 2 bit comparator are we using, or n bit comparator are we using, depends upon the bit type of bit comparator. The number of inputs are depends. And coming to fourth point, its inputs may be varied based upon the bit comparator which we are using, but its output is fixed always, which are, it is having 3 types of outputs. We can say x, y, z, or we can say there are 3 types of comparisons: a equal to b, a greater than b, and then a less than b. These are the 3 outputs which are fixed always. Whatever the type of bit comparator we are using, we may get only 3 types of outputs. Now, sir, let us take 1 bit comparator first of all. Let us try to understand, and then we will go to the next 2 bit, 3 bit and n bit comparator for understand sake. Sir, just note a heading: 1 bit comparator. Make a heading. Here I want to write 1 bit comparator. And now, as I said, it is also combinational circuit. Because this is a combinational circuit, the 5 steps to understand the circuit is similar. The first step is identification of number of inputs and outputs. To understand number of inputs and outputs is the first point. To understand the number of inputs and outputs, sir, we just need to draw the circuit diagram. This is called comparator. I can say that 1 bit comparator. Sir, 1 bit comparator is always having 2 inputs. I can say that which are A naught and I can say B naught. Or also you can write it as A and B are the 2 outputs. And coming to outputs, we can say that there are 3 outputs: X, Y, Z. And X output we can say A equal to B condition, and Y output A greater than B condition, and Z output A less than B condition. There are three outputs. Sir, can I say that here inputs are 2 and outputs are, we can say that 3 outputs. Sir, this is what. And coming to the truth table. Sir, very easy truth table. Here there are 2 inputs, which means 2 power n. We can say 2 square. There are 4 combinations, which are A, B, sir, 0, 0, 0, 1, and now 1, 0, finally 1, 1. We know that this truth table very well. And coming to the outputs, I can say that X, which means A equal to B, and Y, A greater than B, and now Z, we can say A less than B. These are the 3 conditions. Sir, now let us try to understand how to draw these 3 outputs by using 2 inputs A and B. Sir, this is what input, which are free defined input. Now, can you please just tell me, we need to compare A with B. We need to compare these 2 inputs. Sir, can you please just tell me A0, B0, which means both inputs are same. Which means here A equal to B, we need to put 1 here. And now coming to this one, this is a case A greater than B. Sir, this is not satisfied 0. A less than B, not satisfied 0. And coming to the second one, here A is 0, B is 1. Which means A is less and then B is greater. A is less and then B is greater. Which means here A less than B. Which means we need to put 1 here, and all remaining 2 cases are 0. And coming to the third one, here A is 1 and then B equal to 0. Which means we can say that A greater than 1 and then B is 0, here also 0. And the fourth case is A equal to 1, B equal to 1, which means A equal to B, both are zeros. Sir, this is the case. Coming to the third point, sir, logical expressions. For logical expressions, we have 3 outputs, which are A, X, Y, Z, so that we will get 3 logical expressions. Let me write here X equal to, we can say A equal to B condition. What is the output, sir? Here X equal to X of A equal to B. Here for this particular case, there are 2 ones, which means there are 2 outputs are ones and remaining are 0. Here the output equal to 1 when A equal to 0, B equal to 0. So that can I write A bar, B bar. And now the second one is here also A equal to 1 when A equal to 1 and then B equal to 1. So that I want to write this is what AB. Sir, this is what X equal to X of A equal to B condition. And now second case is Y of A greater than B condition. Coming to this one, here there is only 1 and this output is 1 when A equal to 1 and then B equal to 0. So that I can write it as A into B bar. This is second case. And third case is Z of A less than B. I can write it as, here this is output is 1 when A equal to 0 and then B equal to 1. I can say that this is A bar B. Sir, these are the 3 outputs. And minimization point of view, fourth point we can say that, sir, fourth point we can write this X of A equal to B. Sir, A bar into B bar plus A into B. Can we say that this is called A X nor B? Yes. For the sake of space, I want to write this A X or B. This is a fourth point. And now all remaining things are only single term. There is no possibility of minimization further. So let me take A X or B. A into B bar, A bar into B is the final outputs. And now let us try to draw the fourth point here, sir. Sir, fourth point is drawing of logical circuit. Fourth point. Here we have only 2 variables A and B, but there are A bar and also B bar. Sir, let me write here. For A bar, I want to take one NOT gate, and then for B bar also I want to take one NOT gate. Sir, here just for the sake of understanding, X output A and B, X output is A and B. I want to connect one connection here, B connection here, and then here this is what X NOR gate. X NOR gate, A x nor B equal to x of A equal to B case. And now second one is A into B bar, which means this is A and then this is B bar for one AND gate. This is A into B bar for Y case, A greater than B case. And now third one we can say that this is A bar and then B. Here also we need to take one AND gate. This is A bar B and now Z of A less than B. This is the circuit diagram of comparator. Sir, we can say that this is 1-bit comparator, which means we are just comparing A with B. We are just comparing A with B. We are just comparing A with B. We are comparing A 1 bit. We are comparing A bit with B bit. So we can call it as 1-bit comparator. And we have 2-bit comparator, 3-bit comparator, 4-bit comparator also, and we can say that n-bit comparator also. Let us try to understand when there are many number of inputs, 2 bits, 3 bit, 4 bit, which means the number of inputs may be increased and outputs are always fixed. The moment when number of inputs are increased, how many number of equal conditions are there, how many number of greater conditions are there, how many number of lesser conditions are there, there may be a question of asking. Sir, by looking this truth table, we can say that we have only 4 combinations, so that based upon these 4 combinations, there are here X outputs are 2. We can say equal conditions are, we can say here equal conditions are 2. And coming to A greater than condition is 1. And we can say X equal to 2 outputs, Y equal to 1 output, and we can say Z equal to 1 output. And this is possible because this is a 1-bit comparator and we have only 4 combinations. Out of 4 combinations, we can simply tell that there are X equal to 2, Y equal to 1 and Z equal to 1. But coming to 2-bit comparator, which means 2-bit means we can say, we may be having 16 possible combinations, input possible combinations, and 3-bit comparator, 4-bit comparator. To understand and to calculate this, how many number of equal conditions, how many number of greater conditions, how many number of lesser conditions, we have a defined equations which I am going to deal. Sir, let us try to understand.